So today we are looking at lesson 10.7. That's our last lesson in chapter 10. We're going to be focusing today on units of time. This is our conversion chart. Most of these we should know really easily. Hopefully we all know that there are 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, 7 days in a week, 12 months in a year. There are just a couple that might be a little tricky for some of us. And that is that there are 52 weeks in a year and 365 days in 1 year. The exception, of course, being leap year when we have 366 days like we did this year. All right, so our first problem that we're going to look at today is right here. And it's about a computer company that claims its laptop has a battery that lasts for 4 hours. But the laptop actually ran for 200 minutes before the battery ran out. And the question is, did the battery last 4 hours? So just like we did yesterday, we're going to first off identify our question, and that is, did the battery last for 4 hours? And then we're going to look at our information that we have. We know that it lasted for 200 minutes, and we know that we want to compare that to 4 hours. In this problem, they actually suggest in the book that we take this information and that we divide in order to make this unit of conversion. I personally would much rather that we multiplied, because really, it's going to tell us the same information, and multiplying is a little bit easier than dividing. So we want to compare 200 minutes to 4 hours. So we need to either convert minutes to hours or hours to minutes. Well, just like with everything else, if we're going from a large unit to a small unit, we can multiply. So I know that in an hour, there are 60 minutes, and I know that if I have 4 hours, that I can just multiply 4 times 60 and get my answer. Well, 4 times 0 is 0, and 4 times 6 is 24. So in 4 hours, there are 240 minutes. So which one's bigger, 200 minutes or 240 minutes? Well, 240 is obviously more, and so no, the battery did not last for the amount of time that they said that it would. Again, we could have divided, but in this case, it's much easier for us to multiply. I personally am not interested in dividing 600 or 200 by 60. That just seems like a lot of extra work. All right. We're going to take a look at this problem next, and this one is about converting to mixed units of measurement. We've done this before when we've converted to feet and inches, and lots of other different things that we've done. Here we're just going to do it with units of time. So here it says that Jill spent much of her summer away from home. She spent 10 days at her grandparents', 9 days with her cousins, and 22 days at camp. How many weeks and days was she away from home? So question is, how many weeks and days was she away from home? Our information is that we had 10 days at grandma and grandpa's, we had 9 days with their cousins, and we had 22 days with camp. So the first thing we want to do is we want to figure out how many days we were gone altogether. So that's why here in step 1, we see that we're going to add 10 plus 9 plus 22, and that's going to give us, what is that, 30? No, 10 plus 22 is 32, plus 9 is going to mean that she was away for 41 days. Now, if we want to convert days into weeks, I'm going to come over here. I'm going to look at my chart, and I see that there are 7 days in 1 week. I also know that days are smaller units of measurement than weeks. So I need to divide 41 by 7. So I'm going to do that right down here, and 41 divided by 7. 7 is going to go in 5 times, and that's 35. And that leaves me with a remainder of 6 days. So 5 tells me the whole number of weeks that she was away. So Jill was away for 5 weeks. And then this remainder of 6 down here, that means that we had 6 days left over. So she was gone from home for the summer for 5 weeks and 6 days. All right. All of that is pretty much what we've been doing and should be pretty straightforward and easy. The next part of this lesson is about calculating elapsed time, or figuring out when we would start an event or when we would need to end an event if we were given some parameters to go with it. This seems super easy, but for some reason it can be really, really tricky. So take your time as we work through this. One way that we can do this is we can use a number line to help us to figure out elapsed time. This problem says that Monica spent 2.5 hours working on her computer. She started at 10:30. What time does she stop? So one thing that I'm going to take a quick minute to note is that if we are given a start time and given an elapsed time, then that means that we are going to count on in order to be able to find our finish time. So we're going to take a look at this one. We have 10:30. The first thing we're going to do is we're going to jump forward 1 hour, right? Because it says that she worked for 2 hours. We're going to jump forward a second hour. And so if I start thinking about this, well, 10:30 plus 1 hour gives me 11:30 plus another hour means that it is now 12:30. And then I have to figure out 1/2 hour. So let's take a quick break from this problem and let's talk about half hours, quarter hours, and so on and so forth. So if we think about a clock, right, with 12 up here at the top, 6 at the bottom, not 6 on the side, but 3 on the side, and 9 over here. So if we take this clock and we cut it into fourths, hopefully what we can see is that 1/2 of an hour would mean that we would shade in from here to here. Well, if our minute hand is pointing at the 6, then that means that we have had 30 minutes elapse. 30 minutes. If we are only talking about 1/4 of an hour, though, which you'll hear people talk about sometimes. So 1/4 of an hour is actually 15 minutes. And one thing that people very rarely say, but occasionally will come up, might be 3/4 of an hour. And that, of course, would be 15 plus 15 plus 15, or 45 minutes. Oftentimes, instead of saying that it's 3/4 past, people will say instead that it's quarter till. So, for example, if I said that it was quarter till 11, then that means that it's 15 minutes before 11 o'clock, and that would make it 10:45. So this would be quarter till 11. All right, so hopefully that helps out. Let's go back to our problem here. So we've already calculated for the first hour, the second hour that she spent working, and now we need to figure out this half hour. We just talked about it. A half hour is the same as 30 minutes. So if it's 12:30, 30 minutes later, it is going to be 1 o'clock. So after another half hour, we now land here at 1 o'clock. So that's using a time or a number line to help us to count on time. We could do the same thing working in reverse, and that would work out as well. Another way that we can do it is instead we can use a clock. And this is the way that I will frequently do it, especially if there's a clock in the room when I'm trying to figure out what time we need to work until. So here we see that the clock on the right is already at 10:30. And we would just count on in the same way that we did on the last one. We're always going to start with our larger units as we count on. It just makes life a little bit easier. So again, an hour after 10:30, it is 11:30. An hour after 11:30, it is 12:30. And then if we count on another 30 minutes after that, it is going to be 1 o'clock. So again, we're going to kind of look at our clock. We're going to say, oh, well, 1 hour after 10 is 11. Another hour after that is 12. So 12:30 plus another half hour is going to bring us up to 1 o'clock. Both situations, we get the same answer, that Monica finished doing her work at 1 o'clock. And one other thing that we want to quickly note is that because she started at 10:30 a.m., she finished at 1 p.m. So make sure that you're keeping track of if it's morning or evening or afternoon. All right, now here we are. We're going to look same idea, except for instead of finding our end time in this problem, we are going to need to find our start time. So it says that Robert's soccer team needs to be off the soccer field by 12:15 p.m. Each game is at most 1 3/4 hours long. What time should the game begin to be sure that the teams finish on time? So we're given a time where we're going to end, and we need to find out what time we need to start. So anytime that we are given our end time and we need to find our start time, instead of counting on, we're going to count back. And that is, we're going to do it the exact same way using our clock down here. So we know that they need to be off by 12:15. We know that they're going to play for an hour and 3/4, 1 3/4 hours. And so we need to work this out. So what I would do is I would say, well, if they need to be off by 12:15, an hour before that would be 11:15. And I'm going to change the color really quick here to red because I don't like this very much. So that would mean that we're going to be an hour earlier is 11:15. We also talked about how 3/4 of an hour was 45 minutes. And just to make this a little bit simpler, I'm actually going to count these off in quarters. And so because it's 11:15, 15 minutes before that would be 11 o'clock. 15 minutes before that would be 10:45, and 15 minutes before that would be 10:30. So if they want to be off of the field by the appropriate time, then that means that they need to start at 10:30 a.m. So and just to go through that one more time really quickly, we're going from, and let's just make a little bit more space so it works out a little bit better, right? So if we start at if we finish at 12:15 and we count back 1 hour, it is 11:15, and then we're just going to do 15-minute increments. So 15 minutes before that is 11 o'clock. 15 minutes before that is 10:45, and 15 minutes before that is 10:30. So, and again, 1/4 hour, 1/4 hour, 1/4 hour equals our 3/4 hours. And then up here is where we took care of our 1 full hour. And so this is what time they need to start at. All right, let's put some of this information to the test. So on this page, I'm going to go ahead and do a problem, but go ahead. I'm going to pause it after I reveal these other 2 problems. I want you to go ahead and take a minute and try to solve them on your own. I will go through and solve them as well, and we will see how you did, or you'll see how you did. So go ahead and pause it, and we'll get right back to it in just a minute. All right, so 3 years being converted into days. So I know that there are 365 days in a standard year. I'm going to multiply that by 3 to find out how many days I get in 3 years. 3 times 5 is 15. Carry the 1. 18 plus 1 is 19. And 3 times 3 is 9 plus 1 is 10, which means that in 3 years, there are 1,095 days. All right, let's do the one in the middle. 208 weeks. We want to convert that to years. Well, here we're going from a smaller unit in weeks to a larger number in years. So we're going to need to divide. And we're going to divide 208 by how many weeks are in a year? 52. Let's see. And that is going to be exactly 4. So 4 times 2 is 8. 4 times 5 is 20, and we get 2, no, sorry, not 2. We get 4 years. 4 years is equal to 208 weeks. And then our last one over here, we're going to go from 350 minutes to hours and minutes. Again, minutes are smaller than hours, so we need to divide 350 divided by 60 minutes in an hour. I'm going to ignore that 0 and that 0 because I can. I'm just going to simplify things. 6 goes into 35 5 times, which is 30, and that leaves me with 5. So 350 minutes is 5 hours, and then there would be 5 minutes left over. All right, let's go ahead and try a couple of these as well. Here we're going to find the end time on this one, and we need to find the start time on this one. Again, go ahead and pause it, give it a go, and then come back and let's see how you did. All right, so if we are starting something at 11:38 and our elapsed time is 3 hours and 10 minutes, we're going to be counting on. So my little clock over here is already set up. And I'm going to think about it this way. I'm going to say, well, if it's 11 and 38, an hour later it is, whoops, see if we can move that. It is not going to work. It's okay. So an hour later, it's 12:38. 2 hours later, it's 1:38. 3 hours later, it is 2:38. And then all I need to do is add 10 minutes to 38 minutes, and that is going to be 48 minutes. So 2:48. And because we passed the 12 o'clock hour, it's going to be PM. All right, this one, we're going to count backwards. So instead of adding on, we're given our end time and we need to find our start time. So I'm going to do a very similar thing as to what I did in the last one. I'm going to say, well, if it's currently 1:15, an hour earlier, it is 12:15. An hour before that, it is 11:15. And now this part's going to get a little bit tricky because I have 15 minutes after, but I need to deal with 37 minutes before. So the first thing I'm going to do is I'm going to go ahead and make it not 11:15, but 11 o'clock by getting rid of this 15 minutes. That's going to still need to count back 22 minutes. So 2 hours and 15 minutes before is going to be 11 o'clock. Well, 22 minutes before 11 o'clock, it is going to be 10:38. And again, we've passed the 12 o'clock hour, so it's going to be AM. All right, one more. This one's a little bit different because here we are given a start time, we're given an end time, and we have to find the elapsed time. And for this one, you can really do it either way. You can either start with the start time and then count on to get to your end time, or if you prefer, you can start at your end time and count backwards to get to your start time. I am going to start it with my start time and count forward to get to my end time. So 1 hour later, after 7:41, it is going to be 8:41, and then I only have to get to 8:50. So that is only 9 more minutes. So that I know that the elapsed time here is 1 hour and 9 minutes. Now, some of you might be saying, well, Mr. Lovett, can't we just take 8:50 and subtract from it 7:41? And here we see that 41 from 50 leaves us with 9 minutes, and 8 minus 7 is 1 hour. And my answer for you is that yes, in this situation, it would definitely work. But let's say that instead of our event ending at 8:50, let's say that our event had ended at, say, 8:20. Would this idea still work, right? Like, which number do we put on top? Because if we put it this way, it doesn't work out, right? And if we like flip it over and we put 7:41 down here, like, how do we do this whole regrouping thing, right? Because we would have to regroup here, and 10 minus 1 is 9, but then like 1 minus 4 doesn't work. And I can't just pull like a 10 out of here. It gets really, really tricky. So That's part of the reason why we don't do it. The regrouping won't work here because there aren't 10 minutes in an hour. There are 60 minutes in an hour, which means that to this one, we would actually need to add like 6. It's going to get too confusing. We're not going to do it that way. So it is, if it works like this does, go for it. But if there's any regrouping, especially from the hours to the minutes place, let's go ahead and cross that out and don't give that too much of a go. All right, that is our lesson for today. Hopefully this helps out. Again, the elapsed time, that part of things is a little bit trickier than you might think. So take a little bit of extra time with it to try to figure it out today. And I look forward to hearing from you about how your lessons are going, and we'll try another one soon.